Before we get started on the integrating part of this one, we need to go over some trig identities. Whenever you're integrating and you've got more than one trig function, the arguments need to be the same, because if we were going to use that u is equal to sine of 2x for a u substitution, then du would equal 2 cosine of 2x. Consequently, we would have to have cosine of 2x in the problem, not just a cosine of x. So we need to get this to have a 2x in it, or we need to change this so that it's just sine of x and cosine of x. So the identities that we would need would look like there is sine of 2x equals 2 sine of x cosine of x, to transform that one that has the 2x in it. There's also an identity for cosine squared, which is 1 plus cosine of 2x over 2. So I could use this first identity, change everything so that it has an x, or I could use this identity so that the trig functions both would have a 2x. I think I'm going to use this one. So start by replacing the sine of 2x. So we would have integral cosine squared of an x and 2 sine of x times cosine of x. When dealing with trig integrals, it's a good idea to, either on scratch paper or in your mind, try out different u substitutions. If I let u equal cosine, for example, that can replace those. The derivative of that, the du, would be negative sine of x. The negative isn't a big deal. This has the sine of x, so that sounds like a pretty good idea. I'm going to clean this up a little bit. I could factor out the 2 and rewrite it as cosine cubed times sine of x dx. So then this, being inside the cube function, is a good idea for the u of the u substitution. The derivative of that is going to be negative sine of x. Since this doesn't have a negative, so this is matching very well other than that negative sign, just multiply both sides by a negative 1, and we would have that sine of x dx can now be replaced with a negative du. So then if I continue with the integral, I've got the 2 factored out already. This negative I could also factor out. We would then have u cubed for the cosine cubed, and then this part becomes the du, and there's a pretty straightforward integral. It's going to become u to the 4 over 4, and then finally replace u and reduce the fraction, and we would have negative 1/2, and then the u is equal to cosine, so it's going to be cosine to the 4th plus a c at the end. Got the fraction reduced, so that should be it.